Hello, welcome to the next lesson, solving rational exponents. Okay, all right, so let's get started. And this one's going to be pretty much your standard solve for x, except there's this fraction that is in the exponent position of the problem. So it's going to be a kind of a tricky thing to deal with in the beginning. But after a while, you're going to be like, oh, wow, this kind of reminds me of how to solve for square roots. Yeah? So it'll eventually develop into that. And that's what I try to make you guys do, yeah, where I teach you guys a good foundation on something, and then once you guys get to that exact same spot from a similar problem, then you're going to be like, oh, okay, I know what to do already because I've seen and done this kind of problem many times. So that's my goal. All right, so let's see how to do this. And the first step that we're going to do is we want to write this problem so that it is in, I guess there's a radical instead of the rational exponent, which kids nowadays they still freak out about fractions that are in problems, and if you put them in an exponent spot, it's going to make it even worse. So yeah, let's try to get rid of that 1/3. So here's what we do. So 1 equals -3 plus, and notice how the very first part of the problem is exactly the same. Okay, and you're going to turn this into what is called radical form. Yeah, so when you look at this exponent 1/3, you're going to hopefully understand, remember that the top of the fraction in an exponent tells you how many x minus 3's we have. So since there's a 1 on the top of the fraction, that means we have a single x minus 3. So we only have one of them. So we're only going to write x minus 3 one time. Okay? And the 3 on the bottom of the fraction in an exponent tells you where to put the x minus 3, the single x minus 3 that we have. So we're going to put it in a cube root. Okay? So we're going to draw or make a cube root symbol, which looks like that. And we're going to put a single x minus 3 in there. Okay? So some kids might be like, that doesn't look that much easier. Well, if you're like my kids that I actually teach, yeah, they don't ever like to see fractions anywhere in the problem at all. So this is a lesser of two evils, I guess you can say. Okay, all right, so let's solve for x. So solving for x, same thing that we normally do. We're going to get the x by itself, so we're going to get rid of things that are easier to put on that left side first. So for example, -3. Let's get this -3 to go on the left side, and that's easy. We just add 3 on both sides. Okay, so just make sure you follow your algebra rules, right? Whatever you do on one side, you do to the other. Because if you break those rules, then that's when trouble happens. Okay, so then we have cube root of x minus 3 on the right side. Okay, so how do we get rid of this cube root? Okay, so hopefully you guys remember this from your square root lessons where you had to get rid of square roots, and if you remember it, then this next step should look kind of familiar. So to get rid of a square root, you're going to square both sides. So in this case, if you want to get rid of a cube root, you're going to cube both sides. Ooh, I kind of wanted blue for my color to signify that it wasn't in the problem, but I had to add it in there. So let's put blue instead. So we're gonna cube both sides, and because I cube the left side, it's gonna be basically 4 times 4 times 4. And if you guys know your mental math pretty good, then you know it's gonna be 64 equals. And on the right side, yeah, when you cube a cube root, basically what you do is you cancel out that cube root symbol. Yeah, it just pretty much cancels right out. So all you have left on the right side is x minus 3. Yeah, so that's the beauty of cubing both sides to get rid of that cube root, because you just make stuff go away in one single step. Okay, so now we're very close to getting x solved for. So what do you think the last step is going to be? Yeah, just add 3 both sides. Add 3 both sides, and then we get x equals 67. Okay, but I'm not going to box this answer yet because we might have what is called an extraneous solution, which is an answer that comes about because we introduced a step called cubing both sides into the problem. So when we do that, we might have created extra answers that could suddenly pop into our problem that we didn't really want to have there, but because of the cubing step, it's just sometimes a byproduct of that step. So we have to check our answer to make sure this 67 that we just found is valid. Okay, so when you check your answer, here's what you got to do. You got to plug in your 67 into your original problem. Well, not really the original. Yeah, I can change this to the cube root symbol if I want to. So make sure you don't have to put this line, but I tell my students to put this line because then it tells them that they're not allowed to have the two sides interact. So you know how you normally in regular solving for x, you add 3, you got to do it to both sides. You subtract 2, you got to do that to both sides. You divide by a number, you got to do it to both sides. When you check answers, all those rules go out the door. So please don't feel the temptation to whatever I do on one side, I have to do the other. Okay, that rule no longer applies. That rule only applies if you have already proven that the two sides are equal. Okay, and since we're checking answers, that equal sign that you notice was in between the 1 and the -3, yeah, notice how it's gone. Yeah, so we're gonna throw that whatever you do on one side, you do the other rule out the door. We're just gonna simplify both sides. Actually, I was supposed to have put a 67 where that x is. So sorry about that. Okay, so let's put a 67 right where that x is because that's the answer I want to check. So is there anything that I can do on the left side to make it simpler, or is 1 pretty much as small as it's going to get? Yeah, that's as small as it's going to get. So my 1 is just going to carry on down the whole way down throughout all my steps. So I'm just going to work on the right side. So let's just play with the numbers. So -3 plus cube root of 64. Okay, and since this is a cube root, yeah, I gotta look for 3 numbers that match. And if I can find them, I can circle the 3 numbers that match. And because I can circle the 3 numbers that match, they're allowed to go outside the symbol. So hopefully you guys remember that 64 is the result of 4 times 4 times 4. And since we're looking for 3 numbers that match, I think we just found them. 4 times 4 times 4, right? They're 3 numbers that match. So guess what they're allowed to do? They get to go outside the cube root symbol, combine with the -3 that's waiting for it, and when I combine it with the -3 that's waiting for it, we get a 1. So what do we have? What conclusion do we draw seeing that we have the same exact number on both left and right side? Well, this is the conclusion we draw, that the answer is 67 is good to go. So we're happy. That's why I should happy face. Okay, so we can go in and officially circle or box this x equals 67 answer, and we're all done with this first problem. Okay. I'll show you guys another one just to make sure you guys know what's going on. Yeah, in case that one went by kind of fast and you missed some stuff. Okay, I know it's YouTube, so you can just rewind the video, but yeah, sometimes different looks, students get confused because it looks different, but they don't realize it's the same exact steps. So I'll just do another one just in case. Okay, so let's do this one. So we're gonna do the exact same first step that I did in the previous problem. I'm gonna get rid of that 1/6 that's in the power spot, and I'm gonna write it as a 6th root radical. Okay, so I put a 6 right there, and since there's a 1 on the top, that means I have a single x minus 6. And then the 6 is on the bottom, so that tells you what kind of radical I have. It's a 6th root radical. Okay, and we have a 1 on the top, so like I said, that's why there's only a single x minus 6. Wait, it's not erasing. Oh well, I can just leave it that, I guess. Okay, so we just have a single x minus 6 in the 6th root radical. Okay, but our next step is still the same. We're gonna solve for x. So what's the first thing that we should do? Yeah, I know you're tempted to just divide by 3, but no, that's gonna make things worse. Yeah, and it's gonna make things worse because then you have to divide him by 3, and this guy by 3, which is not that bad, I guess, but you could make your life a lot easier if you just subtracted 3 on both sides as your first step. So let's do that. So subtract 3 on both sides. Okay, and then we're going to get 6 equals 3 times the 6th root radical of x minus 6. Okay, and then we can divide by 3, something that you wanted to do in the first step, but I kind of held you back from doing that. So let's divide by 3 now. Okay, so we got left side is 2, right side is just 6th root radical of x minus 6. Okay, and just like in the previous problem when we had to get rid of the cube root, so we cubed both sides, we have to get rid of 6th root radicals, so we're going to exponentiate. Yeah, we're going to go power of 6 on both sides. Okay, and the left side, when I go 2 to the power of 6, and if that is confusing to you, let's just write it out. So 2 times 2 times 2 times 2 times 2 times 2. So that's 6 2's, 1, 2, 3, 4, 5, 6. Okay, so we know that these 3 2's make 8, and these 3 2's make 8, and these 2 8's when combined make 64. Okay, so left side is going to be a 64. That's pretty simple. Then equals, and then the right side, since we have a 6th root radical and we're doing power of 6, yeah, then pretty much that radical symbol is going to disappear right away. So we got x minus 6. Okay, and then the last step before we arrive at a potential answer is add 6 both sides. And then we got x equals 70. Okay, we're not going to officially claim this is an answer because guess what we haven't done yet? Did you guess? Yeah, we haven't checked our answer, so let's do that. So let's check our answer right here. I guess this might be enough space. Yeah, so make sure you put that line signifying that you're not allowed to let the two sides interact. Okay, and then we have 3 on the outside, 6th root radical of 70, which is the answer I want to check because that's the number I have on that left side when I solve for x, minus 6, and then plus 3. So we're just going to play with these numbers. So what do we have? This 9 is going to stay by itself because that's pretty much the simplest it's going to get. We're not going to break it up into 3 times 3 or anything fancy like that. Just leave it as 9. Okay, so 3, why isn't it writing? Okay, there we go. And then 6th root radical of 64 plus 3. Okay, and then hopefully you remember that 64 is the result of what 6 numbers multiplied together? Well, we just did the calculation up there on the top, so if you can see it, then you know it's going to be 6 2's all multiplied together. Yeah, is that 6? 1, 2, 3, 4, 5, 6. Yep. So, because we're in a 6th root radical, our job is to find 6 numbers that match, and if we do, we're allowed to circle them. And because they're circled, we're allowed to send them outside to join the 3 that's waiting for him. Okay, so since everything got circled, that's why the radical symbol disappears also. I don't know if I mentioned that earlier. Yeah, so since everything got circled, all the 2's got circled, there's nothing left on the inside of the radical, so it pretty much just disappears. Poof. Okay, so the 3's outside is going to be joined by the 2. Okay, and here's where kids get confused sometimes. They go, why is it multiplied by 2 when the 2 goes outside? Well, just ask yourself this question. What's connecting the 3 and the radical in the first place? Like, what is the bond between them? Is it being added? Is it being subtracted? And if it was, you'd see a plus or a minus sign right there. But since you don't see any operational symbol at all, then you can assume it's multiplication. So that's how you know when 2 jumps out, it's going to multiply to the 3. Okay, then plus 3 on the end. Okay, then order of operations is going to take over. You're going to multiply first. You're going to make 6, then plus 3, then you got 9. So when I compare the left side and the right side, are they the same number? And if it's the same number, that means that 70 is good to go. It's a legit answer, so we're happy. So I draw a happy face. And 70 is your legit answer. You can box it. We're all done. Okay. Hope you understood this video, and I'll see you next time.